Okay, so this is a revision for Calculus 2. And these are some rules that we have seen in Calculus 1. Okay, so this is the derivative. Okay, so this is multiplication of two functions here, u and v, and we take derivative according to x. So let us say u is a function in terms of x and v is a function in terms of x. Okay, so here the multiplication, the product rule says that, okay, write the first one, take the second one's derivative, plus write the second one, take the first one's derivative. Okay, so this is product rule. Derivative of a constant is always 0. Derivative of x according to x is 1. And here ln u, derivative of ln u is derivative of u over u. And you can see this is cosinus formula, tangent formula, and here these are two functions, u and v. Derivative of these functions is just, you can take derivative of the first one, plus, if it is a plus sign in the middle, you will put a plus. If it is a minus sign, you will put a minus, and you are going to write derivative of the second one. Now, this is a fraction, okay, derivative of a fraction. Derivative of the first one multiplied, you see that derivative of the first one multiplied by the second one minus derivative of the here denominator multiplied by numerator over denominator square. So this was the formula of a division of two functions, derivative of division of two functions, u and v. Now here, if we have powers, n is a power here, so how we find derivative of u? Let us say u is a function in terms of x. Here what we do, we put n here, and we subtract 1, and we multiply derivative of this u with this here. Okay, and we have some other formulas here that we use often, exponentials. Now let us pass to our Canvas platform to other formulas. Okay, I close this screen. Now these are trigonometric rules 0 we see, and let us see 2. Waiting to open. Okay, I am downloading it in order to make it bigger. Maximize it. Okay, this is better like that. Okay, so here these are other formulas that you will need for Calculus 2. These, you know that from Pythagoras theorem we can have this sinus square theta plus cos square theta equals to 1, and we have these trigonometric formulas here. So you know that core function identities were these ones that you have studied in Calculus 1, and these were the periodic identities that the signs changes or the trigonometric functions changes according to addition or subtraction of p, 2p, and here these are general transformation, cotangent, tangent, secant, cosecant. We have seen this also in the PDF before. So we have some rules like when we have minus odd identities, when it is minus here, you can have this minus with this sinus sign, and with cosinus sign you have the same thing, and with tangent you have the minus sign. These were also other formulas that we have seen in Calculus 1 courses. Sinus of 2 x and y, here the addition and subtraction, sum and difference formulas, these are called. These were the formulas, so you have to know all these by now. These are just recalling the formulas from Calculus 1. You know, maths consists of lots of formulas. We cannot avoid them. It's also important to know some formulas as well as how to solve questions by using these formulas. Okay, so this is sinus, cosinus, tangent here. Formulas, this is sum and difference formulas. We have product formulas. You must recall this even from high school that you have been seeing until now. There are law of signs. These were also in the high school subjects. And law of cosines, double angle formulas. You can see there are lots of formulas for double angles to theta. You can see when we have sinus to theta, cosinus to theta, or tangent to theta, we have several formulas regarding to this. Yes, and area of a triangle, we also have this formula and should be discussed also in Calculus 1. Okay, so let us pass to the other rules from here. These are some rules from Calculus 1, and they are available to you, as I say, from the files section in your Canvas platform. So here, what else we have? Integral rules. Let us pass to the integral rules that you have seen. Yes, I maximize it a little bit. Here there is a power rule of an integral x to the power n. You can write xn plus 1 over n plus 1 and plus a constant, okay? So you know that n cannot be minus 1 because it becomes undefined. And here this is x minus 1. This is this 1 over x, integral of 1 over x is ln x. These are exponential formulas, e to the power x. This is ax over ln a. Okay, constant multiples, like derivatives in integrals, so we have constant multiples, and before taking integral or derivative, we can have them in front of our symbol here. So we can multiply k at the outside here, and we can find derivative of this function f here, and then multiply with k. Okay, here there are sum and difference formulas. Here you can see, like in derivatives, summation and integration is just we can do it in normal way. We can if there are two functions fx and gx, and if we want to find their sum, we have to find first of all integral of this fx and then integral of this gx, as you can see here. And this is the difference formula. We have to find integral of this fx minus integral of gx. Okay, now let us pass to the other formulas. Across this, let us see what else I have here. I put different differential rules. Let us see this one. Yes, we have seen this one. Yes. Did we look to this one? Let me look. This is similar to the other ones. Okay. So I am going to put some other formulas to this section as you need. Okay. So you will find many formulas from here to solve your assignments, homeworks. And let me, since I'm recording now, let me recall where you will find assignments. You are going to find your assignments here.